In this lecture, we are going to discuss how to solve equilibrium of a rigid body in 2 dimension. So, to understand the rigid bodies, we need to know for each support what is the reaction. Okay, so just first we find out the supports and its reactions in 2 dimension. So these are roller supports. This is a rocker. It is a frictionless surface. And you see there's a short cable, inextensible cable. There's a link, short link, and something moving in a frictionless. There's a slot and a frictionless pin, and collar on a frictionless rod. Now, for all this, you need to find out what is the reaction, what is its sense. We also have these supports. When we will have reaction, if the motion in a particular direction is prevented, then that direction we will have a reaction. Say roller will roll and move in x direction, so the reaction will be only in y direction. Rocker also can rotate and slide, so the reaction is in y direction. Frictionless surface, the body will have reaction in this direction. So now what we need to understand is the line of action of the reaction and its sense. Okay, so this frictionless surface, the reaction is perpendicular to the surface, pointing to the body. So this is the body. The reaction is perpendicular to the surface and pointing to the body. So the line of action is known, the sense is also known. But for these two, the line of action is pointing to the body, perpendicular to the surface, but the sense is not known. So what to do if we do not know the sense? We will see in a couple of minutes. Okay, so for this frictionless surface, the sense is known. For all this, the line of action is known. Now here, for the short cable, you know very well the cable will exert always a tension force away from the body. So the line of action is known and the sense is also known for short cable. But for short link, the line of action is known, but the sense we do not know. What to do, we will see. Here, in both the cases, the line of action of the forces will be perpendicular to the slot and collar, because that direction is prevented. So the movement in that direction is prevented. So it is the line of action is known. Again, sense we do not know. We can assume initially. Upon solving the problem, we will finalize which direction the reaction is going to be. When we solve problem, we'll understand. For this, a frictionless pin, it is hinge. Hinge will rotate. So, but x direction the motion is prevented, y direction also the motion is prevented. So x and y are prevented. But so this is the resultant, nothing but this is the resultant. So you can write like this also, or the components. So just I'll explain with respect to the components. So we have x direction prevented, y direction prevented, but we do not know the sense for frictionless pin hinge. We do not know the sense. But for rough surface, y line of action, as you know, it is perpendicular to the surface pointing to the body, perpendicular to the surface pointing to the body. The sense for y component is known. Like or frictionless surface, y component is known. For friction surface also, the y component sense is known. Very important point, it is known. But this direction we do not know based on which direction this is moving. If it is moving in this direction, friction will always be opposing the motion, then the reaction will be opposite to the motion direction. If it is moving in this direction, then it would be opposite to the motion. For this, both the directions are unknown, but we can initially assume and then find out based on the value whether it is positive or negative. We have to change the direction. We'll see that in a minute. Now for fixed support, all three, what are all the possible three motions in a plane? X direction, y direction, about z direction, rotation. So the rotation about z axis is prevented, x axis movement is prevented, y axis also prevented. So all the three will be there as reaction. So this is nothing but the resultant, and it is x and y component. And all the three reactions, the sense is unknown. The sense of the reactions can be known after solving the problems. Now, generally for equilibrium of a rigid body in 2 dimension, you know, this is very important. Z direction force is not present. So about mx or x-axis, about y-axis, the moments are 0. Only moment about z-axis is present. Force about z-axis is absent for the forces in a plane. So the equations of equilibrium become summation of fx equal to 0, summation of fy equal to 0, summation of moment about any point equal to 0. So here where A is any point in the plane of the straight line. So there are three equations. So obviously there are three equations. We can find out three unknowns. The three equations can be solved for no more than three unknowns, as we know. See here, summation of fx, summation of fy, moment about any point. Here you can also have another set of equations, but only three equations. The equations cannot be augmented with additional equations, but they can be replaced. Fx is present, moment about A is present, moment about B is present, so that the body is in equilibrium, the unknowns can be obtained. So this is a typical case where we will be straight away write the equations. On seeing this itself, we'll be able to write the three equations. So we can choose these three equations accordingly, appropriately. To easily solve the problem, if we take summation of fx equal to 0, straight away I will be able to, so this is the free body diagram of this. So we'll have a reaction here. We know the direction because it is a string, so we know the direction. Okay, we have three inclined forces. The reaction Rd can be straight away found out, summing all the x components. So one equation straight away I can use this equation. Now another two equations if you use, or if you take moment about C, see here, this will not produce a moment. This will not produce a moment because the line of action is passing through C. Only this will be the unknown. So I'm choosing an equation. Okay, so straight away I need not solve simultaneous equations to find out the unknowns. Straight away I will be able to find out the unknown because in this equation only one unknown, Rb. Similarly, if you take this equation about, if you take moment about D, this will not produce a moment. Obviously, this will not produce a moment, and only this will produce a moment. So this is unknown, RA. Straight away, I can find out the reaction at A. So what did we do here? We choose equations to easily solve problems. In all problems, it is not possible. Wherever possible, we have to appropriately choose the equations to solve the problems. Now, statically indeterminate reactions. So you see this structure at A and B, it is hinged. It means this is the free body diagram. So we have two reactions here. Hinge will have two reactions. X and Y are prevented. So two reactions. These two directions are assumed. And this will also have two unknowns. Now, we cannot have equations more than three to solve two-dimensional rigid body equilibrium problems. So here, if you see, more unknowns are there than the equations. So this is statically indeterminate. Definitely you cannot find out all the four unknowns. Here you see there are fewer, only two unknowns. We have chosen two rollers. Sometimes coincidentally, if x components goes to zero coincidentally based on the magnitudes, then sometimes it is in equilibrium, but generally it is not. So here the number of unknowns are fewer, so it is partially constrained. It is statically indeterminate system. Now here, if you see, there are three unknowns, three rollers being used. It is also improperly constrained because it will rotate. Okay, but sometimes, as we discussed the previous case, the x component can be balanced, so it will go to zero. In that case, it will be in equilibrium. And certain applications are there. The screens being moved, so it can be used. But all the places it is not possible. It is also a typical example for improperly constrained. About A, you cannot have equation at all. Moment equation cannot be written about A. It will go to zero straight away. So we cannot find out the unknown. Statically, we cannot solve the problem. For such cases, we have deformable body concept, and there we have additional equations. Then we can solve that problem, which we'll learn in strength of materials or mechanics of solids. Now, summing up, so the condition of equilibrium for space and for two dimension, generally we use these three equations. With these three equations, we'll be able to solve all the equilibrium problems. Okay. Now we'll see quickly couple of examples. See this, there's a crane, there's a weight hanging, CG will be acting here, the total CG will be acting here, the weight will be acting here, weight of the crane will be acting here. This is the additional weight that is hanging, and it is supported here. And what is this support? Yes, it is a hinge, and it is a rocker. So rocker will have, okay, the line of action will be perpendicular to the surface. The sense I do not know, but I can assume. Here also we will have X and Y as reactions, and since we do not know what is asked, the reactions we have to find out. So three reactions, hinge will have two and rocker will have one. So we will be able to find out all three reactions in this problem. Let us see the free body diagram. So it is converted into kilonewton and 9.81 kilonewton. Okay, and I am assuming AY, AX, and the reaction here. The sense I am assuming in this direction. Now how to solve? We have three equations. Okay, summation of fx equal to 0, summation of fy equal to 0, summation of moment about any point equal to 0. So first, summation of moment about a equal to 0. Okay, if I take moment about a, these two will not produce a moment. These two unknowns are going off. Only this will be the unknown present in the equation. These two are known forces. So about a, B will produce a moment. So summation of moment about A equal to 0. B is the force, reaction force. You can use RB or anything. So B about A, it will produce a anti-clockwise moment. You see the sense which I have assumed. Anti-clockwise. About A, it will produce anti-clockwise moment. What is the perpendicular distance? 1.5. What is the moment definition? Force into perpendicular distance. Okay, the line of action of this force and a line passing through A, about which I need to take moment, which is parallel to the line of action. The distance between two parallel lines is the perpendicular distance. So B into 1.5, since it is an anti-clockwise moment, so it is positive. Now this force will produce about A, this will produce a clockwise moment. So it is 9.81 minus, okay, minus 9.81 into the distance is perpendicular distance. So what is perpendicular distance? Line of action of the force, a line drawn passing through A parallel to the line of action, and this is the perpendicular distance which is given here. So this is the clockwise moment. Similarly, this is also a clockwise moment with a perpendicular distance 6 equal to 0. You have to use equal to 0. Now B is the only unknown. You'll be able to find out plus. What does it mean? Now just recollect what I was discussing during the supports and reactions. There I said the sense can be obtained after solving the problem. Initially, I assumed a sense because I do not know the sense. Okay, I assumed a sense. It is right towards right, and the found out value is positive. That means my assumed direction is correct. Okay, now we need to find out these two reactions. So what are all the equations left with? We can use summation of fx equal to 0. So how many x-axis forces are there? 1 and 2. These are in x direction. So always right side is positive, left side is negative, and ax I have assumed towards right, so I am putting positive, and b, and I am able to get my ax equal to negative. In this diagram, straight away we can put this opposite because it is right side. Only two forces are there to balance each other. One has to be opposite. Directly we can assume, but then you can assume anyway and solve, and then you get ax equal to negative 107.1. That means this is in this direction, Now ay, to find out ay, summation of fy equal to 0, ay minus 9.81 minus 23.5, because always we take upward positive, downward negative, equal to 0, and we are able to get ay positive. That means this assumption is also right. This assumption is also right. This assumption is wrong. So it will be opposite. Check the values. We will solve some more examples in the next lecture.